Welcome back to my channel, GTR Math Tutorial. So for today's video, I will discuss integrals of powers of tangents and secants. So we have integral of tangent to the mu times secant to the nu dx. U here are in terms of x. So function of x ang u natin. Okay, so we have case 1 when m, so the exponent of tangent is any number, and n, so this n, the exponent of secant is a positive even integer greater than 2. Okay, so the exponent of n is positive even greater than 2. So we may write tangent to the mu secant n to the nu equals tangent to the mu, and then we have secant to the n minus 2u times secant square u. Okay, so we're just going to factor secant square so that we can use the u to the n du. So we have, okay, so what will happen if the exponent is 2? So we have a condition, integer, positive even integer greater than 2. Because if the value of n is 2, we can simply solve this. For example, if we have tangent, m is any number, we have tangent cube, and then the exponent of n is just 2, secant square, let's say the angle is x dx, we can simply solve this using the u to the n du. So here we will let u equals the tangent x, and then we know that the differential of tangent x is secant square x dx. So now this can be transformed into the value of tangent x is u, and then we have exponent 3, and then du is secant square x dx, which is this term. So it's now in the form u to the n du. So that the answer to this now is u to the 4th over 4 plus c. So we have direct formula if the exponent, if the n is just 2. So we just use this formula, integral of u to the n du. So the final answer for this, so that's a direct formula. We have tangent to the 4th x over 4 plus c. Okay, so that is why the value of n should be greater than 2. Positive even number greater than 2. Okay, so this should be 4, 6, 8, and so on. And then we factor secant square, and the other will become secant to the n minus 2. And then we can use the identity secant square u equals 1 plus tangent square u. Then after using this identity, we're going to reduce the given integral to the form. So we just factor secant square u dx, and then the other is sum of powers of tangent. So that we can use this formula, direct formula, if we have sum of powers of tangent, because we know that the derivative or differential of tangent x is secant square x dx. So that is why we have a factor of secant square u dx, because all of these terms are powers of tangent, and the derivative of tangent is secant square u. Okay, so that is our main objective, to reduce the integral into this form, sum of powers of tangent u, and then we have secant square u dx. Okay, so before we start the discussion, I have two examples here. Integrals of powers of tangents and secants. Case 1, exponent of tangent is any number. Exponent of tangent is any number, and exponent of secant is even number greater than 2. So before I discuss that, so try to screenshot first and try to answer on your own before watching my solution. So this is my my playlist, my channel, GTR Math Tutorial. I have playlist for integral calculus. So as you can see, I have differential calculus and integral calculus. So I will just view the full playlist, and then I have all the discussion from basic integration formulas up to integrals of powers of sine and cosines. And I will discuss it all the topics on integral calculus up to application. Volume, area, volume of solids. Okay. Okay, so let's start. Number 1, we have tangent square 2x and then secant to the fourth 2x dx. And number 2, integral of square root of tangent x secant to the 6x dx. That's answer number 1. Okay, so for number 1, so we have this is the m, any number, we have tangent square, and then we have exponent of 4. So first step is we break this secant to the fourth 2x, so we factor the secant square 2x. Okay, so this will be integral of, just copy this, tangent square 2x, and then subtract 2 to the exponent, so we have secant square to the 2x, and then times another secant square 2x dx. Okay, so we just separate this factor, secant square 2x. And then we're going to convert this or transform this into powers of tangent only. So we will use the identity for the other secant square 2x. Okay, so use the identity. So we have tangent square 2x, and then the identity for secant square 2x is 1 plus tangent square 2x. And then times this, we have secant square 2x dx. Okay, so next step is just distribute the tangent square 2x to 1 plus tangent square 2x. So therefore, we have tangent square 2x times 1. So we have tangent square 2x plus, just add the exponent, tangent square 2x times another tangent square 2x, that is tangent to the fourth 2x. And then times secant square 2x dx. So now we will let u. So let u is equal to tangent 2x, and then the derivative or differential of tangent 2x is secant square 2x times derivative of 2x is 2 dx. So we put the 2 here. So we have 2 and then dx. So as you can see in the original integral, we don't have 2 in this secant square 2x dx. So that's why we're going to have a neutralizing factor of the reciprocal of 2. We have neutralizing factor of 1/2. Okay, so we just need to multiply this by 2 and then outside the integral 1/2. So it is now in the form, u to the n du. Okay, so our exponents are 2 and 4, so just add 1. So therefore, the final answer is we just multiply by 1/2. So we have 1/2 times, it's in the form u to the n du. So there, our u is tangent 2x. So therefore, we add 1 to the exponent. So therefore, we have tangent to the 2 plus 1, 3. The angle is 2x over 3 plus 1/2, or we have neutralizing factor of 1/2. 1/2 tangent to the 4 plus 1. So we have to the 5th, 2x over 5 plus c. And just multiply by 1/2. The final answer is tangent cube 2x over 2 times 3, we have 6, plus tangent to the 5th, 2x over 2 times 5, we have 10, plus c. So this is the final answer for number 1. Okay, so next, number 2. So we have square root of tangent x times secant to the 6x dx. So just factor, we need a factor of secant square. And for square root, so we convert this into rational exponent. So we have is integral of, we have tangent raised to 1/2. So tangent raised to 1/2 x, and then we break this into secant to the 4th x times secant square x dx. So we just separate this secant square x dx, and we need to convert this into powers of tangent. Okay, so secant to the 4th, that is equal to secant square x and then square. And then use the identity for secant square x. Okay, so therefore we have integral of tangent raised to 1/2 x, and then we have secant square x. The identity for that is 1 plus tangent square x, then we have square, times secant square x dx. So now we apply the square of binomial. So we have binomial here, 1 plus tangent square x. a plus b squared, that is equal to square the first term, a square plus twice the product of first and second term, 2ab plus square of the last term, b square. Okay, so apply this square of binomial formula to this. So therefore, we have tangent raised to 1/2 x, and then 1 square still 1 plus 2 times the product of 1 plus tangent square. So we have 2 tangent square x plus the square of tangent square. So we have tangent to the fourth x times secant square x dx. So it's now in terms of tangent only, powers of tangent. So we just distribute this, distribute the tangent raised to 1/2. So therefore, we have tangent multiply by 1. So it's still tangent raised to 1/2 x plus 1/2. Just add the exponent. So we have 2 here. So just move the constant across the integral sign. So we have 1/2 plus 2. So 2 can be written as 4/2. So we have 1/2 plus 2 is 4/2. So therefore, that is tangent raised to 5/2x plus add the exponent 1/2 plus 4. 4 can be written as 8/2 since 8 divided by 2 is 4. Okay, so therefore we have plus, okay, so let's put this in parentheses. And let's remove first the integral sign here. So we have 2 tangent to the 5/2x plus we have 1/2 plus 8/2. So we have tangent raised to 9/2x times secant square x dx. So now we can use the integral of u to the n du since our u here is tangent x, and we know that the differential of tangent x is secant square x dx. So we don't have neutralizing factor. So we just need to add 1 to the exponent and then copy it in the denominator. So therefore, we have 1/2 add 1. Okay, so we have tangent raised to 1/2 plus 1. So plus 2/2. So we have tangent 3/2 over 3/2 plus 2 times tangent 5/2 plus 1, that will give us 7/2 x over 7/2. And then last, we have plus tangent 9/2 plus 1, we have 11/2. Then we have angle x, and then over 11/2 plus c. So just simplify this. So 2 will go up to the, pupunta yung 2 dito. So we have 2 tangent 3/2 over 3. And then for this, so we have 2 times 2, and then 2 will go up here. So therefore, the final answer will be 2 tangent 3/2. So we forgot the x here. X over 3 plus we have 2 times 2. So we have 4 tangent 7/2x over 7 plus tangent to the 11/2. We have x over 11. Then we have 2 here. And then plus the constant of integration c. So this is our final answer. Okay, so that's all. So I hope you learned something from this video. Thank you for watching. And see you on integrals of powers of tangent and secant case 2. Okay, again, thank you for watching. Bye-bye and God bless.